What are these tropical storms?
Yeah, 5 different, kind of a third letter. Most air masses have how many letters? 2. Okay, we need moisture and temperature. Right. All right. So now we get to talk about, we talked about 5 different types of air masses, and where air mass A meets air mass B, we call that a front, just like Army front, right? It's an air mass front. Okay. And usually, and we call that actually the transition zone, that's the front, the zone, transition zone between those 2 air masses, and that's where life can get a little interesting. You can have lifting mechanisms that actually can bring you precipitation, but when we talk about in Unit 4 the severe weather, the thunderstorms, lightning, and all that stuff, tornadoes, cumulonimbus clouds, they actually can oftentimes be associated with a cold front. So there's 5 types of fronts that I want you to get under your belt. Kind of starting from right back to left again, we have cold front, warm front, stationary front, and occluded front. And notice that actually their color, they have a color to them, but they also have kind of like a symbol, like we have triangles associated with cold front, what we call semicircles with a warm front. A stationary front, we're actually going to see, you can see semicircles and triangles, right? And occluded front as semicircles and triangles, but they're on the same side. Okay. So these are all the fronts. Now, this says the direction of the arrows with semicircles show the movement. Okay, so actually, this one, this is kind of from right back to left again. This is, well, I'll show you in a minute. So let's look at each of those 4. So a cold front, and actually I put this on my little hints for your test on Friday. Notice that the direction of the triangles, it's pointing this way. So actually your whole air is moving this way, and the air that's being what I call the aggressor is cold air. And it's moving into warmer air. Now it's relatively speaking, right? Okay. And usually cold, that'd be like a cold, let's go ahead and use what we talked about Friday, right? Cold air mass. Cold air mass on the moon. All right. A warm front. I'm not sure why it kind of almost shows this concave sort of thing. I need to track that down. But clearly you see this the semicircles on the other side. So actually the direction of motion is that way. And so this is our warm air mass over here. And it's going that way. Okay, so the front is named by the air mass that's aggressive. Well, speaking of the air mass that's aggressive, the third one is a stationary front. There's no movement. It's a standoff. Yes, it's not moving. So if it's a standoff, but still you can see which side of that line, the front, that your warm is on. So if we kind of see, for instance, the semicircles, looks like it's going that way, but it's not moving. Can you see where this is our warm air mass? Warm. And then the top is our cold air mass. So it's a standoff. And last but not least, we have something called an occluded front. So occluded front kind of looks like a stationary front, but what's different is that the semicircles and triangles are on the same side. So again, you can see the direction that it's moving is this way. Let me pick green. So it's moving this way because I can tell. And we'll talk about what an occluded front is coming up. But basically, it's alternating semicircle, triangle on the same side, and the whole thing is kind of moving that way. All right, so Chapter 9, and I kind of get it. Chapter 9 spends a lot of time talking about something called a mid-latitude cyclone. And the term cyclone hopefully should ring a bell in this unit of material. When we talked about at the surface, we have these L's or we have these H's at the surface. And if you have an L, we call that a cyclone. Okay, and we talked a lot about those surface lows, and winds are going counterclockwise. Get this wrong sometimes, right? Counterclockwise around the low, we talked about that. So just a general cyclone is an L. But mid-latitude cyclones are those, like the slide says, that kind of occur between Alaska and Florida. The Ferrel cell, mid-latitude cyclone. So the thing about a mid-latitude cyclone, and the thing about a mid-latitude cyclone is that this actually isn't its mature stage. I'm going to try to kind of convince you of this. But can you see where this low, this cyclone, has got a pair of fronts? Okay, it's got a cold front. It's swinging around counterclockwise. It's got a warm front swinging around counterclockwise. Okay. The other thing, we've been talking about this a lot in Unit 3, is that, do you see the MBs? Those are pressure. Okay, and you can kind of see the bullseye thing going on there. And it kind of looks like those are isobars, right? Those white circles, they're pretty tight. Okay, and so the tighter they are on the isobars are, the stronger the wind. So this is kind of the beginning of something called a mid-latitude cyclone. Kind of looks like a mustache, I think. So that was the beginning, and this actually is a snapshot of a mature mid-latitude cyclone. Kind of get your bearings, it kind of looks different, right? So notice you kind of see the mustache. Let's see, let's pick on green, okay? Notice we have the central low, the cyclone going on, right? We have the cold front, okay? We have the warm front. I like this slide because notice that actually we talked on Friday. What does CP stand for? Continental polar, yep. And MT? Maritime tropical, exactly. MP? Maritime polar. Okay? So we have those kind of three sectors. And what I think is kind of cool, I've heard especially cyclones more than anticyclones, but they're kind of like a blender. Okay? Like a kind of Popeyes, yeah. They're kind of like a blender, kind of mixing it up. But notice I call it a mature stage because what else does it have? It has that thing called an occluded front. Okay, so an occluded front is usually purple and it's alternating triangle, semicircle, triangle. And that's actually kind of where the mustache is. You have your cold front, your warm front. That little thing, that's occluded front. Okay. And we'll talk more, like I said, about occluded fronts coming up. So one of the things I like about your author, can you see that segment A and B? Okay, what he's done is to, in some of his figures, I'll pick on purple maybe. In some of his figures, he's actually taken a segment like that and he shows it in a separate figure. Is that not cool or what? So here's A and here's B and here's what's going on between A and B. It's a, it's a busy place. Notice that AB starts in this sector, the continental polar. It moves into the maritime polar, and it also comes out to the, moves into the maritime tropical, the middle one, and comes out to the maritime polar. And that's actually all that you see down here. Kind of the three sectors going on. So one of the things I've talked about, we've talked a lot in here, I guess, maybe, is that cold air is denser than warm air. And that's a player. So basically, this cold air, you see the word hugs? We're going to kind of keep that in mind. Cold air is more dense and it will scoot along the surface. It's just more dense. Warm air is more fluffy. Okay, so here you have your cold air hugging the ground. All right. So let's kind of pick apart the warm front and the cold front before we talk more about the occluded front. Okay, so this isn't necessarily about a mid-latitude cyclone, but this is just about a warm front, just in general. And I told you, if you see that red line kind of going up with the semicircles, okay, warm air mass on the move, okay. I forgot what I was going to say. But anyway, so the thing about that warm air is that it is not as dense as the air it's trying to ultimately replace. So we have this cool thing, and this actually is on your unit exam, something called overrunning. So basically, you see this warm air will ultimately replace this cool air, but in the meantime, this cool air is stubborn. Okay, so we have this aggressive warm air and it moves up and over. It's kind of like, I've never really seen participate in one, but like those mosh pits where, you know, they can pass people, you know, it's up and over, right? And so we call that overrunning. The thing about it is if you were here, let me draw a little person. Here's my little stick figure. If you were here, okay, kind of watching the clouds, and this whole system is going this way, because of overrunning, what you first see, and actually there's like old wives' tales that say this. You know, if you see the mare's tails, cirrus clouds, you know, high wispy clouds, actually that could be an indication of overrunning. So it's going to start with your high wispy clouds, and then you're actually going to stay with, it's stable. Okay, it's not a bunch of, not cumulus sort of clouds, but you have your layer clouds that ultimately can bring you precipitation. Okay. So one of the things, we're going to talk about cold front here in a minute. Both fronts, warm fronts and cold fronts, can give you precipitation. Remember, nimbostratus clouds are those ones that are precipitating on us. Okay, but precipitation with a warm front is nice and gentle and prolonged. Actually. Now, I prefer this version. This actually is a warm front with stable air. Your author does present another type of warm front, and the difference here is basically the chunk of air that you're lifting up has a degree of instability. Okay, so I know that they're saying warm front you can get, of course, CB or cumulonimbus clouds. I hope you're kind of thinking storm clouds. Okay, your author says you can get a degree, it's possible to get storm clouds out of this, but. So we say that the transition zone between the warm air that's kind of encroaching in on the cold air, the transition zone has this crazy slope. So, I mean, it's like a long slope, gradual slope. So, then there's, for each, the warm and the cold fronts, your author put together kind of a series of what to expect before, during, and after. I think, yeah, that should work. So now compare those figures, or especially the first figure we looked at for a warm front, with this figure for a cold front. So the deal with the cold front, I already said cold air hugs the ground. If it's a cold front, then that means that the cold air is aggressive, it's on the move, and it's going to try to replace the warm air in front of it. But since it hugs the ground, basically it's like a snow shovel. We've seen too many of those this last season, haven't we? So basically it has this really what I call abrupt transition zone. Okay, so that warm air, it goes up, okay, quickly. And so one of the things we know about air as it rises, it will expand and cool, and that's why you can get clouds, and that instability actually can bring you this storm cloud.
Frontal wedging.
Yeah, this will be frontal wedging, exactly. Yeah. So, yeah. So the things that, and actually this is how it's worded on the test, I think, the things that make, that bring us our severe weather with our cold fronts are two. One is that it's moving very fast, and the other is that it has a very abrupt lifting going on. All right, and here's kind of the similar what to expect before, during, and after the passage of a cold front. All right, so stationary front, that's the standoff. That's the alternating red, blue, semicircle, triangle. Okay, so basically they're not moving. But even though it's kind of a standoff at the ground, what can happen is basically at a little bit upper elevations, your warm air says, oh, I think I'm going to go on over my cold air. Okay, so actually that's the overrunning we talked about. Down here at the bottom it says it's hard sometimes to identify if a front is moving or if it's stationary. Well, to me it's hard to identify anything in meteorology. Air masses, where's the circle around air mass? You know, where's the line for a front? But they do. All right, so that purple occluded front. The word, In the word occluded front is the word occlusion. And we say basically an occlusion has occurred if basically a chunk of air has been lifted up. I know I kind of used like overrunning as kind of a mosh pit, but this really is definitely a mosh pit. So to understand why we get a chunk of air lifted up, kind of to form an occluded front, you need to remember that cold air is more dense, and that cold air actually will go faster than warm air. So those two things will kind of get you to an occluded front. So I'll kind of show you how this works. So I mentioned a little bit ago that we actually have three sectors of air. We kind of, with a kind of even just a mustache, we have a low, we have a cold front, we have a warm front. Our three sectors are here, here, and here. Okay, three sectors of air with just a cyclone. So you figure this sector over here that's coming down from our north is cold air, and it is actually going to outrun the warm air in front of it. Okay, and so when it outruns the warm air in front of it, it catches up with the air that actually was in front of the warm front. Okay, and it lifts some of this air. So if on a test I ask you, which I might, how do you get an occluded front, or how does it work? You can basically, if you use the word outrun, cold air mass outruns the warm air in front of it, that would be worth 3 points. Right there. Okay.
So you're saying basically warm air outruns the cold air mass?
No.
The other way around. Cold air outruns the warm air in front of it and meets up with the cooler air in front of the warm front. Cold air mass outruns warm air mass in front of it. Yep. And there are at least 2 types of occluded fronts, and I don't get into the 2 types. This one's a cold type, but you can see the similarities between this one, and here's another figure. This is a warm type. What they have in common to me, if I don't kind of read the captions, is you kind of see a chunk of air that's being lifted up. And the other thing they have in common is that the cold air is outrunning the warm air in front of it. And kind of slightly different air masses, but it's the same idea. And they're cool. No pun intended. So this could be a 5th type of weather front. So weather fronts, we think of cold front, cold air is the aggressor, a warm front, where warm air is the aggressor, a stationary front, where it's a standoff, an occluded front, and this could be a 5th type of front, where the 2 types of air masses that are meeting, they're both warm, so any type of air mass that's warm gets the T designation for tropical, but one's dry, continental tropical, and one's moist, maritime tropical. So we have those 2 air masses meeting. And if you remember, and this is actually on your test, we said on Friday that continental tropical air masses only form in the summertime. Yeah, in our southwest, but they're only summertime. They're just exclusive to summertime.
So what is that again? So I understand.
Continental tropical air masses only form in the summertime.
Wait a minute.
Yeah.
Arctic.
And Arctic polar only form in the wintertime. Exactly. So here the deal is, and this is kind of counterintuitive. You know how like humid days, oh my gosh, the weather seems, or the air seems so thick, but actually moist air is lighter than dry air. Okay, so here we go. It does seem backwards. So basically, hugging the ground, you have your dry continental tropical air, and then kind of be lifted, you have that moist tropical air. That's kind of how that works. So this actually is a little table to show you, I can't remember what this location was, but to show you the passage of a dry chunk of air. So now, here's the deal. We said that dew point temperatures were important to indicate the humidity. We said basically if your current temperature is 66 and your dew point temperature is only 2 degrees below that, it's pretty muggy, okay? You only have to go 2 degrees to cool it down, okay? So notice then the passage of dry air. So these temperatures, these are the surface temperatures, 66, 71, 77, 78, 80, 85, 75, excuse me. Pretty warm, right there. But what changes is right here. Look at your dew point temperatures. it went from 62 to 46. So, and here at 3 p.m., you have to lower the temperature from 78 to 46 in order for it to do it again. What does that mean? It means your air is pretty darn dry. Yep, so right there is the passage of a dry. All right. So, mid-latitude cyclones. They have three fronts. Of course, in the middle of a mid-latitude cyclone is your L. That's what they call a cyclone, right? You have your occluded front, and it's kind of like a mustache. You have your cold and your warm, right? So there's this chapter talks about two ways that you can get a mid-latitude cyclone. I'm going to show you some pictures, and one thing about a mid-latitude cyclone, I hope you understand, is they are humongous. And I think, like a previous slide says, they can last for days. It's just a weather system, mid-latitude cyclone. So the one I'm going to spend a little more time on is called the polar front theory. Now, hopefully you guys remember where the polar front is. So we talked about three cells, the Hadley cell, the Ferrel cell, and the polar cell. Just to remind you, the polar front is between the Ferrel cell and the polar cell. That's the polar front. So go clear up there, and that's where it begins. This sort of polar front theory to formation of a mid-latitude cyclone. So cyclones are low pressures, right? And in the northern hemisphere, they're going counterclockwise. Okay, they're going clockwise in the southern hemisphere, but counterclockwise in the northern hemisphere. So a few pictures then. And actually, hopefully, this will kind of reinforce maybe a little bit how do you get that occluded front there? Yeah. So this, to me, is not a mature mid-latitude cyclone. Why? Because it lacks the occluded front. I don't see a purple line. But here's the deal. Can you see what's that?
It's still showing the circular motion and stuff like that.
It will always show counterclockwise, whether it's a mature mid-latitude cyclone or not, around a central low pressure. I guess I should show you the last figure on here. So segment A and segment A to segment B is being shown right here. So it's kind of like Joe said, if you think of the circulation, okay, and I said that cold air will outrun warm air, that's what's going on there. So that cold air is going to outrun the warm air in front of it. The best place it can do that is where it doesn't have to go very far. So actually, it's gonna your occlusion is gonna start right here, kind of I guess you call it the vortex. So your occlusion starts right there where they're joined, because this outruns this and lifts it up. So this is this. Excuse me.
You know, where they meet, where there be more intense storms possibly? Or...
Mm-hmm. Yep, we're going to see that on a few slides coming up. Okay, so maturity, I think so. The difference between those two is now we have an occluded front. And actually, on some of the figures that included in your textbook, we're going to see here's where we get those isobars that are really kind of getting pretty darn tight. So at maturity, that's when you start to kind of whip it up into a frenzy. But you see that middle sector was lifted up now. It's being lifted up. And air, especially moist air that's being lifted up, can go ahead and condense and precipitate. So the gray there actually is precipitation. And actually this is on your test. If you think of the punctuation mark, a comma, okay, so, I don't know, a comma has kind of like that, okay? That actually is very similar to, this is the precipitation, this is the clouds, kind of this shape that the clouds form. That's why they call it forms a comma shape. Yeah, where we have this abrupt lifting by the cold front. Okay, we have overrunning here. Okay, to me it almost looks like a two-legged comma, but so that's mature mid-latitude cyclone. And then, of course, systems die eventually, and to me this is kind of the dissipating stage of a mid-latitude cyclone. If you look at the fronts on the surface map, we definitely have, you can kind of see the tail of a cold front, the tail of a warm front, and this big old long occluded front, okay? That's kind of the end part before it just kind of disbands. We call that elongating the occluded front. But did you see in those three figures kind of it moving kind of along with the mid-latitude westerlies? We said kind of changing the ferrule south. All right. So coming up in a few slides, I basically list in 6 easy steps how do you get a mid-latitude cyclone using this polar front model of getting those mid-latitude cyclones. And so here they are kind of, I call this 1, 2, 3. Basically what they say it starts out with is a stationary front. Stationary front way up here. Does that seem like it could be bumping up between the ferrule and the polar cell? I think so too. Okay. Then it gets a wave develop. Okay. Sometimes I've heard that called a kink. Just kind of a little kink. And with that kink, it kind of breaks out then into its two, kind of a mustache thing going on. Still not a mature mid-latitude cyclone though, is it? Because it doesn't have the occluded front. And then finally down here, at this stage, we do go ahead and get your occluded front. It's mature, and yeah, it should have the winds that goes along with maturity, precipitation. Okay, we have elongation here. Okay, and not shown here, it basically just dissipates into nothing. So that's a mid-latitude cyclone. And it generally goes from the west to the east, but it does have kind of it depends on what the Rossby waves and the jet stream are doing to kind of steer it. Sometimes you think that weather pattern, it's like got us in its sights. It just wants to be mean to us, but I don't think it really does. Especially hurricanes, you're like, they have a personality. They're after us. So mid-latitude cyclone. The word cyclonic flow means in the northern hemisphere, cyclonic flow is counterclockwise. And I think I might have mentioned this before. Whatever hemisphere you're in, cyclonic flow is the same direction as the Earth is rotating on its axis. So actually, Earth is rotating counterclockwise. If you look at the bottom of the Earth is rotating actually clockwise. Okay, and so cyclonic flow down there is actually clockwise. But anyway, not necessarily at maturity. You guys who are used to looking at surface maps kind of see this mixed map. The fronts are drawn in, but the greens and the oranges, of course, that's precipitation, right? Kind of see the comma? So these are the 6 stages of a mid-latitude cyclone. Sometimes I include this on my test. I didn't this semester, so you're off the hook. But this is what we talked with the polar front model of how these mid-latitude cyclones come to be. So this is a mid-latitude cyclone in its mature stage. You can definitely see the 3 fronts. You know, the front closest to the central low, of course, is your occluded front, and then it kind of breaks off into your cold front and your warm front. And so, you know, I've shown this several times, and this did make it to your test. So basically, I'm going to want you to either describe or draw a mature mid-latitude cyclone. You get a note card, goodness sakes, okay? So what your author did was to kind of show the top of the comma, really, G and F, and then actually what he's done is go E to A, kind of showing you down below there. Mature mid-latitude cyclone. And this is not a figure, but actually this is a satellite image of cloud cover, classic comma. Okay. So we generally, these low pressure, generally everything will follow the prevailing wind. Although we know that winds aren't always a westerly wind. The wind isn't always out of the west for us. And these are actually, each line represents a different path that mid-latitude cyclones generally take. And so you've heard of the term nor'easters. Okay. Those actually are mid-latitude cyclones that follow that red line right there. Mid-latitude cyclones. And if you're like me, the polar front theory that we've talked about doesn't really explain how do you get those mid-latitude cyclones, I don't think as much. But I'm going to take us to, on Friday, remember we got to watch the snowfall, that time last video? So this time, for the same event, the Boston event, I think this is right. I'm going to show you, take you out to the website. Actually, that crazy snowfall was not lake effect snow. That crazy snowfall actually was kind of one of these mid-latitude cyclones, specifically called a nor'easter. Now, and I had forgotten this till I looked at this article, but do you remember when they were talking about, I'll dim the lights a little bit so you can see better, storm surge? And usually, people might be shaking their head, storm surge, and if you're like, because if you follow hurricanes much, you know that when hurricanes hit anywhere, when the hurricane goes to landfall, there's this event called a storm surge. So basically, with a hurricane, it's basically whipping up all this ocean water, and here's my land here, okay, and basically it kind of, it's like, oops, I guess I should be going like this, counterclockwise, okay, final answer. So counterclockwise, and basically it's like if you're in a pool of water and you're just going like this around in circles, moving that water, okay? So basically it just moves that water onto land, that storm surge. So it's weird to get storm surge with something other than a hurricane. Hurricanes have this cool, crazy, low pressure high. And when it hits landfall, that's the storm surge. So actually, it's kind of strange. So I like what they did. These was it you were telling me about or somebody?
The waves coming in and the ice on the houses.
Yeah. The waves coming in, the ice on the houses. So you can see that we have before and after. So this is what it looked like before, and this is what it looked like after. Isn't this cool? So this is before. Beautiful, beautiful. This is after. So a nor'easter did that, coming in off the Atlantic Ocean. What is a nor'easter? A mid-latitude cyclone. And then if we go down, kind of the before again is on our left. So this is before. One more. This is the before. Can you imagine those houses? So we've got a series of slides that go with this slide, and I meant to track this down. Do you guys, I'm a UNI alum, so go Panthers, right? UNI didn't quite make it in the tournament, but that's okay. Anyway, their Unidome, their inflated Unidome thingy, actually it crashed, maybe was it 94 or 93, a student is looking this up for me. But we think that, your textbook might mention that was the event, that was a mid-latitude cyclone in its mature stage, basically came across. The problem with mid-latitude cyclones, when they're mature, you can get anything that's associated with a thunderstorm, you get it. So lightning, thunderstorms, tornadoes, thunderstorms, hail, thunderstorms. The other thing about mid-latitude cyclones is you can get anything associated with a blizzard sometimes. Okay, just how crazy it's going, I know. But they'll see March 21st, 22nd, 23rd, and 24th. Now, I mentioned steering maybe a minute ago. Basically, those upper level winds we've been talking about, those kind of steer large systems like this. So a couple of possibilities of what the upper level winds are doing, kind of from left to right, I've shown you. Of course, if I were to ask you on a test something like, which one's more meandering, you probably would say the right one, wouldn't you? Does it look more meandering? And the first one looks more zonal. Yeah. So we have some possibilities with regard to steering and what these systems are going to do. Okay, so starting out, day 1, March 23rd. Okay, not in its mature stage. You know, we've been talking about those black lines now are isobars. And not all the time do they mark what the pressures are for the isobars, but they did for this one. So for instance, all locations on this line are at 992 millibars, and looks like it's going out by 4 millibars, so 996. Okay, plus 4 is 1,000. Okay, so you kind of get the idea. Those are isobars. Not real tight, but you know, remember tight isobars, the tight pressure gradient, you get lots of wind. So that actually is before it's mature. This is in its mature stage. Okay, how can you tell? You see the extra front there. Do those isobars look wound up? Yeah, I think so. I like this over here, you know, as we've been talking about an aerial view of the cloud cover, hopefully that reminds you of a comma. Not to be confused with a coma. So, and yeah, feel free to follow this up in your textbook, but I'm pretty sure this was the unidome got flattened. So if you compare that picture with this picture, okay, and you try to find your, if you try to find your cyclone, okay, there's our cyclone now. Notice we don't have those tight isobars, okay. It's got just the remnant of an occluded front, so not all occluded fronts are nasty weather. That doesn't look too nasty. I guess it depends on if you're in Maine or not. Oops. All right. So, we talked about mid-latitude cyclones, right? That's a cyclone. And if it has kind of those characteristics, occluded front, cold front, warm front, you might be thinking mid-latitude cyclone. Yeah, it's mature. And we talked about how actually those 6 stages, you can get them starting with the polar front. This is an alternative to the polar front model, the conveyor belt model. And to me, this probably makes more sense with maybe than those nor'easters that we saw kind of kicking off of the inner Atlantic. So if you think of a conveyor belt, conveyor belts, think of them in a factory. Basically, they are a moving belt and they relocate stuff. Okay, where you want it to go. That's a conveyor belt. So the stuff being relocated in this case are chunks of air. So conveyor belt model. So let's see if you can kind of see. Well, first off, you see underneath there your cold front and your warm front. Okay. And it looks like a really busy diagram, but you can kind of see warm air being lifted up and over. Okay, there's their one conveyor belt. And actually descending dry air. So actually, this is all I'm going to say about this alternative, this conveyor belt model to form the mid-latitude cyclone. But what it does is it creates your fronts. Of course, we don't have an occluded front being shown there. But that's not too hard to kind of maybe imagine the cold air outrunning the warm air in front of it. Very good. Okay. So, cyclones, mid-latitude cyclones. Hopefully by now we're kind of all thinking L's for cyclones, not just Iowa State. Anticyclones, hopefully you're thinking H's, because we talked about those surface patterns with a big old H. We call that an anticyclone. And the term meridional, okay, we talked about earlier. And so if this is kind of the jet stream or upper level, if this is like upper level winds, okay, that waviness is meridional flow. Those could be called Rossby waves, right? Kind of repeating it as a Rossby wave. And we talked about actually you can have alternating, well, let's see. We call this a trough. I usually have to concentrate. We call this a ridge. Okay, we already said ridges are associated with highs, right? And troughs are associated with lows. So if this whole thing is, and I feel like it might be right now for us here in the Midwest, if this whole thing is kind of moving like it should, you should get alternating cyclone, anticyclone, cyclone, anticyclone. And then one of the things I told you, with highs, generally speaking, these are usually clear skies, and with lows are cloudy. And I haven't looked recently, but I'm kind of thinking we're getting that alternating pattern. That's assuming things are moving. Okay. So here is kind of a, if it looks like something we talked about before, the fact that weather here on the surface of the Earth, you know, go ahead and kind of circle the surface high and the surface low. We said that those surface highs and surface lows, the anticyclone and the cyclone, they really need 3 dimensions in order to be sustained. We said basically your high will, high stuff is moving away from your high, right? So if it doesn't have stuff feeding it, it's going to turn into a low. We said your lows, we have stuff converging, and if we don't have stuff getting out of the way, it's going to turn into a high. So we kind of actually sort of talked about this. Here you see it, actually your high is being fed, and here you see that your low is, we said the air has to rise there to kind of keep it there. And so here now, up at upper elevations is showing, I think we may have talked about this before, is kind of showing you how do you get the air coming down to sustain a high, or how do you get the air going up to sustain a low. And one way is actually by speed divergence. And this kind of makes sense to me. This is like it'd be at upper elevations. So basically, if it's going fast, it's going to create a high pressure. Or excuse me, if it's going from not going fast, it's going from a slower speed to speeding up. So if it's accelerating, it's going to basically create a high. If it's slowing down, decelerating, it's going to create a low. That's backwards. Oh. Well, maybe I said it wrong. Yeah, I think I said it wrong. I'll double check this. Thanks for catching it. But so accelerating. Let's look at this again. So if I have just normal bunches of particles around me, and if I go from a low speed to a high speed, actually I am creating less dense. So that is a low. So accelerating creates a low, and slowing down bunches up creates a high. That makes sense. Yeah. So it is right. The other one is actually has to do with vorticity, and that's just basically if it's kinked up or kind of on a long grow, and it's called directional divergence, and it actually can create air moving vertically too. But aside from that, it's like what I just showed you on the previous slide. I drew a Rossby wave, or I wrote meandering at upper elevations. And for the troughs, the low spots, I put an L, and that's your cyclones. And for the ridges, I put an H for your anticyclones. Yeah. Nothing to fill in there. So we just have a few more slides, but I think I'm going to hold these slides hostage. Now let's go ahead and finish these. We've got a minute and a half. And then come on Wednesday, because I'll have something cool for us to do. I promise. Okay? Anticyclones, I'm hoping that somewhere in your connection you're like H's, anticyclones. And I'm hoping in the northern hemisphere you're thinking clockwise. Right? And the other thing, I wrote clear. Remember for your highs? I wrote anticyclones are generally clear. So if somebody says, an anticyclone is coming, an anticyclone is coming, you're like, hallelujah. Well, you know, I'm saying clear skies, right? So they don't need to be that big of a scary thing. But if anything stalls, whether it's clear skies or whether it's cloudy skies, if you have a stalling sort of situation, and I think Dirk used that term recently in one of his segments. That's not a good thing. So high, if it's clear, that actually can bring drought conditions, and in this case, this actually looks like an Arctic air mass is associated with this high pressure, which is not good. And then kind of finishing up things, if you have ongoing cloudiness, that's not good either, especially if you have rain falling from those clouds. So I have a couple of slides that look at the flood of 93 and the flood of 08, which is near and dear to some of our hearts around here. So these are photographs of the 08 flood. This one over here is Cedar Rapids. Crazy. And this is just a kind of memory lane in the flood of 93. Okay, so there's two types of floods. There's prolonged precipitation gives you flood, and kind of what we call flash floods. So that was because of a blocking high, even though. Okay. All right. So I'm going to stick with me. I know I said you can bring this to do your test on Friday. Okay. The test is still Friday. Come Wednesday. And I won't cover new material, but come Wednesday. Might be a quiz Wednesday. So 9, instead of making it due Wednesday, I'm going to go ahead and make it due Friday. You can bring it Wednesday if you want, but usually, I don't mean to throw you off, but I had it in my mind that it would be due Friday. So you can bring it Wednesday or Friday. How's that?